There are 3 theorems to prove that two triangles are similar. So first, it's important to know that triangles are similar if one of them can be dilated to fit the other. The first theorem is side-side-side similarity. If all the corresponding sides are proportional, then the triangles are similar. In this first diagram, we have two triangles, ABC and HGF, and we want to know if the corresponding sides are proportional. Well, first we need to determine what are the corresponding sides. So first, the longest side of each triangle. So the longest of the triangle on the left is 84. The longest of the triangle on the right is 14. And we'll see if that's equal to the second longest or the middle length of each triangle. So the middle length for each triangle is, for the first one, that's 72. And for the second triangle, that would be 12. And finally, the shortest side of each triangle, if they are the same proportion, then these two triangles would be similar. So the left triangle, the shortest side is 48. The triangle on the right, the shortest one is 8. So now I'm just going to check to see that these are all the same proportion. So let's see, 84 over 14 is 6. 72 over 12 is also 6. And 48 over 8 is 6. So since all of these are equal to 6, then these two triangles are proportional. To label this, we will say triangle ABC is similar to triangle HGF. Now let's look at example 1. Triangle EFG is dilated by a scale factor of 1/5 with a center of dilation at 2, 2 to form the new triangle XYZ. Which statement is true? Well, first we need to know that dilation only preserves proportion. So triangle EFG is not going to be congruent to triangle XYZ because it's 1/5 of the size. So they are not equal in measure. That means we can go ahead and mark out the statements that have the two triangles congruent. Okay, the next thing we need to know is that if we want to prove similarity, and we know that the scale factor is 1/5, then that means we know that the original triangle has been shrunk by 1/5. So the side lengths are not the same, but the angle measures will be. The second theorem that proves similarity between two triangles is called Sideangleside. If two corresponding sides are proportional and the included angles are congruent, then the triangles are similar. So the sides need to be proportional, but the angles in between them must be congruent. From this diagram, I want to remind you that we talked about vertical angles at the beginning of this unit. That's anytime two lines intersect, the opposite angles are congruent. Now we can check to see if the longest sides and the shorter sides are proportional. The long side for the triangle on the left is 14. The long side for the triangle on the right is 49. And we want to know if that's equal to the proportion of the shorter legs or the shorter sides. So the shorter side of the triangle on the left is 8, and the shorter side on the triangle of the right is 28. So we just need to know, are these proportional? So 14 over 49 and 8 over 28 are the same decimal number. Another way you could do that is by just simplifying the two fractions. So the biggest thing that goes into 14 and 49 is 7. So 7 goes into 14 twice. 7 goes into 49 7 times. And we can simplify the fraction on the right. The biggest thing that goes into 8 and 28 is 4. 4 goes into 8 2 times. 4 goes into 28 7 times. So these fractions are both equal to 2/7, but you can always put them into Desmos to double check and just look at the decimal numbers to see if they're equal. So the two sides are proportional and they have an angle between them that is congruent. So to show you this a little bit clearer, we have the triangle on the left has two sides that are proportional to two sides of the triangle on the right, and the angle between those proportional sides are congruent. So we would write our congruent statement as triangle MVL is similar to triangle TVU. Notice the order matters. Example 2, determine whether the two triangles are similar. If so, state the scale factor. So the scale factor is the factor that you would get when you simplify the fractions of the proportions. So we'll start by just finding out if they are similar or not. So I can take the long side of the top triangle, which is 18, over the long side of the second triangle, which is 42, and see if that is the same proportion as the shorter side. So the shorter one of the top triangle is 9, the shorter one on the bottom is 21. So first we need to know if these are proportional. So we can check in Desmos, 18 over 42 and 9 over 21. They are proportional, and we want to check that they are similar by seeing if we can use the Sideangleside theorem. All right, so we have the two sides that are proportional, and we have an angle between them that are congruent. All right, so we have in the top triangle, we have these two sides that are proportional to these two sides on the bottom triangle, and that degree measure of 76 is between the two proportional sides. So that is side-angle-side similarity. So we'll say yes, they are similar. Okay, so triangle UVW is similar to triangle. Now this is important. We've got to make sure that we get the letters in the correct order. So triangle U corresponds with angle F. V corresponds to G. And W corresponds to H. So yes, they are similar. And what is the scale factor? The simplified fraction is another way of writing the scale factor. So if we look at the biggest thing that goes into 18 and 42 is 2. So the biggest thing that goes into 18 and 42 is 3. So the biggest number that goes into 18 and 42 is 6. 6 goes into 18 3 times. 6 goes into 42 7 times. And the largest number that goes into 9 and 21 is 3. So 3 goes into 9 3 times. 3 goes into 21 7 times. So the scale factor is 3/7. So what that means is the original triangle, we'll say UVW, is 3/7 the size of FGH. The third theorem is angle-angle similarity. If two pairs of corresponding angles are congruent, then the triangles are similar. We're actually going to do 2 examples to talk through this one. So let's test out this example and see what we get. All right, so in the first triangle, he has 2 angles, 26 and 35. It doesn't really matter where they are. We are just testing this out for the sake of visual purposes. And the second triangle has a measure of 119 and 26. So we know that all 3 angles in a triangle have to add up to be 180. So 180 minus 35 minus 26 is 119. All right, so that leaves us with the second triangle. We'll call this angle Y, has to be 35 because those 3 numbers add up to 180. So since all of these angles are the same, that means that the 2 triangles are similar automatically. We don't need any side information. All right, in example 4, 2 angles in a triangle measure 50 and 45 degrees. If a second triangle is similar to the first triangle, what is the measure of the largest angle of the second triangle? Okay, well, if the 2 triangles are similar, they're going to have all 3 angles congruent anyway. So what we need to know is what is the largest angle, because these 2 triangles are going to have all the same angles anyway. So 180 minus 50 minus 45 is 85. So let's just say if we did have this triangle and we had these angles 50, 45, this one up here would have to be 85. So if another triangle is similar to that, it might be larger or smaller, but the angles are still going to be the same measures. So the largest angle is 85 degrees.